I am going to do an example from the textbook which might prepare you for question number 1 on your homework tonight. So this is on page 221, and here's what it says. The position of a particle is given by this, which is kind of a curious situation. But I typed this into my calculator, and I came up with these numbers. So in other words, when t is 0, the position is 0, where this is some particle that's maybe traveling on a number line. When t is equal to 1, the particle is at 4. When t is equal to 2, the particle is back at 2, 3, 0, 4, 4. So let's kind of look at what's going on here. We have a number line. The clock starts ticking. We're going to start ticking when t is equal to 0. So according to this equation, when t is equal to 0, this little particle is right over here at 0. In 1 second, right, by the time t gets to 1, the particle has zipped all the way to 4. Right, now I don't know if it's gone straight there or not, but I'm going to assume here it is at 4, at t is equal to 1. When t is equal to 2, the particle has somehow gone back to 2, and by the time t is equal to 3, the particle is back at 0. By the time t is equal to 4, the particle has zipped back to 4, and then by the time t is 5, it's zipped all the way to 20, and it's just going to keep on going in this direction. So this is what this little particle is doing. Now, here are a few things. At some point, we know that the particle is going right and then turns around and goes left. And I'm not so sure if it turns around and goes left right at 4, or if maybe it like travels to 5 and then zips back even quicker. I don't really know this. So we're going to use calculus to figure out what's going on here. So for part A, they want to find the velocity. Well, velocity is rate of change of position. So that's just the derivative. So the derivative here is really easy, 3t squared minus 12t plus 9. And then the next question is, what is the velocity after 2 seconds? So I can plug in 2, right? So that's going to be easy, 3 times 4 minus 12 times 2 plus 9. So that's 12 minus 24. So this is going to give us a negative 12 plus 9. And we get a velocity of negative 3. And here's why this is a little bit interesting. This is the particle after 1 second, or 0 seconds, 1 second. So after 2 seconds, so at 2 seconds, the particle is sitting right here. But because the velocity is negative, this is telling me that this particle is heading right back to where this little guy started, right? Heading in the negative direction. And if I wanted to find the velocity at 4 seconds, well, that's going to be 3 times 4 squared is 16 minus 12 times 4 plus 9. So that's 48 minus 3 times 16 is 48, I think. And then minus, so that's minus 48 again, and then plus 9. So my velocity after 4 seconds is 9. And what I know is that after 4 seconds, right, here's the particle, and it is heading in this direction. And notice 9's magnitude is much bigger than 3. So in fact, it is hightailing it to the right at that point. Now, there are some other things. The other thing might be, when is the particle at rest? Well, when the particle is at rest, the velocity's got to be 0. So let's look at our velocity function and set that equal to 0. I'm going to factor out a 3. Which leaves me with t squared minus 4t plus 3. Okay, and I can divide both sides by 3, and then I'm going to factor this polynomial. So t minus 3, t minus 1 is 0. So I know this particle is at rest after 3 seconds and after 1 second. And again, here's what's going on. So it is in fact true that the particle at 1 second is at 4, and at that point, right, at t is equal to 1, the particle has stopped moving. Which makes sense because he is turning around. And then by the time 3 seconds elapsed, the particle is back here at 0. And again, the particle is turning around. So that's kind of interesting. Part D says, when is the particle moving forward? When is the particle going in a positive direction? So in other words, when is the velocity positive? Notice the velocity was negative when the particle was over here. Well, what I can tell is that the velocity must be positive. I'm going to say it looks like from 0 to 1, and then the particle turns around, and then it goes in the negative direction. And then from 3 to infinity, it looks like this velocity is positive. And here's how we can also do this. we're going to consider our velocity. And what I'm going to do is just sort this out in terms of where velocity is positive and negative. So if I'm looking for an inequality where something is greater than 0 or less than 0, I'm really going to look for where this is equal to 0. So again, I'm going to set this velocity equal to 0, factor out the 3, right? So I have t squared. We've done this before, right? I know this is going to factor into t minus 1 and t minus 3. So what I know is that if I was going to look at my velocity function, so I'm going to have a number line, and I'm going to label this velocity. And I know that velocity is 0 at 1 and at 3. However, if in fact, I'm going to look at my velocity in this factored form, t minus 1, t minus 3. So here's what I know. This is where the velocity is equal to 0. If I, however, took anything in this region, right? If I plugged 4 into my velocity, if I plugged 5 into the velocity, that would give me 3 times, let's say it's a 4, that would be positive, that would be positive. So all over here, in this whole interval, the velocity is positive. If I look between these two, let's just call them critical values. If I look between these critical values where the velocity is 0, if I tested 2 in this factored form, that would give me positive 3. 2 minus 1 is positive, but 2 minus 3 is negative. Well, a positive times a negative is just negative. And in fact, if we could go back in time and look at this before t is equal to 0. So if I just plugged a 0 in for t, I'm just picking something easy from this interval, that would give me a negative times a positive, and that's positive. So this is called a sign analysis, S-I-G-N analysis. And it gives me some indication of what's going on. What I know is that the particle moves right until t is equal to 1, and then it moves left until t is equal to 3, and then it moves right forever after. Oh, and one more thing. In order to find the total distance traveled by the particle during the first 5 seconds, well, we can do this. We can start with our position at 0, we know is 0. This is going to turn around after 1 second, and s of 1 is 4. So that's a total of 4 units. But then, by the time we get to s of 3, right, when this particle turns around, we know that this is 0 again. So we know that the particle has moved back those 4 units. And then, by the time 3 seconds have elapsed, we're only moving in the positive direction. So let's see. S of 5 is going to be 20. So from 3 to 5 seconds, this has gone 20 units in the right-hand direction, so that's 20 units. So in 5 seconds, the total distance traveled is 28 units.